Yeah, there's good work there. I have a good view. Oh, wow. And I've started it already.
I typically grab the.
I originally thought that I just saw that.
I just like kick it
Tall enough. I had to borrow one from another shop, but hey, it works. No, I feel like I'm just trying to figure out what the question is.
30.
Just gotta figure out my timing. No.
I turned mine all off though.
Good. Always enjoy it.
You guys will have to remember, you're gonna have to remind me to turn them all on tomorrow or I will be forever late.
Oh, can't be that bad. Good morning.
Good morning.
Are we awake?
Not yet.
I'm Anthony Purcell. I teach at Longfellow Middle School. I'm teaching 6th grade math. Just so I know, elementary teachers, raise your hand. Middle school, high school. All right. That gives me kind of an idea of what I'm looking for or how to approach my audience, how to talk with you, things like that. This is really just helping students just understand mathematics. And to give you a little bit of insight, first of all, where's your focus? There's too much focus on learning procedures without connection to meaning, understanding, or the applications that require these procedures. And I've seen this in several places where a lot of people just, teachers just teach how to do the math, but then as students get older, they don't understand why that works. It's just there. And so with some of that understanding, lack of understanding, then they're actually not able to even do the math later on because they've lost that understanding. So if they have that understanding, it helps. The first video I wanted to share, it is the butterfly method. For those of you who aren't, who don't really know what it is, I'm going to play this little video that I found. I want you just to kind of listen to what she has to say. Are there things that you agree with, or things that you don't agree with? Just take a chance and listen and watch. Possibly. I check myself. There we go.
We're going to learn how to add and subtract fractions, but instead of doing the method in which we find the common denominator, we're going to use the butterfly method. Okay, so what you're going to do is you're going to actually make a little butterfly. So we're going to need the wings. Also keep in mind, whenever you're doing the butterfly method, it is only for adding and subtracting. You do not do this multiplying and dividing. So we got the butterfly wings. We need the antennas, and then we need a body. So we've got our butterfly, but what do we do with this butterfly? Well, if you look at the wings, you might have seen this before when you cross multiply. So that's exactly what we're going to do. Whenever we're adding and subtracting fractions, doing the butterfly method, we're going to multiply, then we add. So let's do 2 times 2, which is 4. 4 times 1, which is 4. So we cross multiply, and then we also need to multiply in the body. So 2 times 4 is 8. Now that we multiplied, now we can add. So the two numbers we multiply on top and the one on bottom, we add together. 4 plus 4 is 8. And then we also have the 8 as the denominator. And we know that 8 over 8 is equal to 1. So,
All right, so let's start there. What do you agree with what she said? What do you agree with? What do you mean by nothing?
Well, you don't know why, I mean, you don't know why you're doing it. I mean, it's, and when it applies to addition and not multiplication, nobody's gonna remember that. It doesn't make any sense why you do this.
It's just another process.
It's just techniques, yeah.
You don't understand what a fraction is.
the thing that I really enjoyed was at the very beginning, how many caught what she said right away? Instead of finding a common denominator, what? If you take a look at this, I mean, I know are mathematically minded, we can look at this. Is 8 really a good denominator to have? We can all look at this and see that 1/2 is equal to 2/4. And so, right away, if you're just teaching students to go to this method and don't even process switching and what fractions are equivalent to other fractions, you're going to be at a loss for the kids. Okay? Take a look at the next one that she decides to use on it.
So 1/2 plus 2/4 is equal to 1. That's our answer. Okay, now we're going to do the butterfly method with this problem here. So let's draw our wings, in which we will cross multiply. Draw our beautiful butterfly wings. We're going to draw our antennas, in which we'll do our cross multiplication answers, and our body. So cross multiply, then
Now, when you watch this one, it kind of makes a little bit more
8 times
sense
2,
because 8 and 3, when you're trying to find that common denominator, you are going to multiply.
is 9.
But I think the process or the understanding of it is getting lost in this situation because a lot lot of kids are going to focus on making a butterfly and not so much on what they need to be doing.
This is addition sign. We have 9 plus 16 gives us 25. And then our denominator is 24. We could also simplify that and making it an improper fraction. And when we do that, that would be 1 and 1 over 24.
Okay, another thing that kind of bothers me in this video a little bit, I know we're not so much Common Core, but this is where I first started hearing about it, was getting rid of the term improper fraction. There's nothing wrong with it. In fact, middle school, high school, as you start getting into the higher level math, is there anything wrong with that fraction, 25 over 24? There's nothing wrong with it. So calling it an improper fraction is telling students that it's wrong. And it's not. It's just a fraction. And so helping students understand that process will help as well. But again, when you look at this one, it makes a little bit more sense, but it's still not helping students fully understand why that works. And so being able to teach them how to go from 3/8 to 9/24 makes a lot more sense for students. So, what could you do? Teaching fractions is important, especially at the younger age. I know it's probably one of the most difficult things to teach, to help students to start understanding that. Middle school level, I've taught 8th grade before. It is still always a struggle. And we just have to continue to rely on each other to all be teaching it. You can't say, well, they didn't learn it in elementary school, so I'm not supposed to be teaching it. No, we have to continue to reteach that and help them understand it. Using fraction strips to help them understand how to add or subtract is another thing that really is helpful. For instance, when looking at that problem, that first one we had, where you had 1/2, and you're adding 2/4. When they have the fraction strips and can actually see what can go together, they can see that taking these things here, bring it over, you can see the half that's here, bringing it, and it helps the students understand that a little bit more. Should you take maybe 1 or 2 days to teach that? Yeah, it's going to take a while. Are some kids going to get it right away? Definitely. Are some going to struggle? Definitely. And that's where you have to be reaching and helping those kids actually understand the process that is happening and not just drawing a picture and saying, well, this is just a quick way to do it. Okay? Now, I called it kill the butterfly, but really there's so many different methods that we need to look at to see what we can do. How many have seen the turtle? in multiplication. All right, well, here you go.
The turtle head method makes multiplying larger numbers simple. Let's multiply 27 times 65. First, draw the turtle's head. Multiply by the number in its neck, 5. 5 times 7 equals 35. So we'll write the 5 and carry the 30 3 tens to the next column. 5 times 2 equals 10, and 10 plus 3 equals 13. Now there are 3 important steps before we go on. Check off carried numbers, draw a collar, and lay a turtle egg, 0. Now we can multiply by the other number, 6. 6 times 7. Some students have trouble remembering the product of 6 times 7. Let's watch a clip to see an
Now
easy
she's
way
totally
to
gone off into a whole other tangent, not even talking about how to multiply, but now let's look at 6 times 7.
How many legs? 42.
Now we know that 7 times 6 and 6 times 7 equal 42. So we'll write the 2 and carry the 4 to the next column. 6 times 2 equals 12 plus 4 equals 16. The last step is to add.
How many people now see a lot more steps in this than the actual algorithm takes? Okay, but it's teaching the kids this little trick on how to multiply this. But kids are going to spend time drawing their turtleneck and drawing the collar. You got to make it look pretty, and you're losing what they're actually doing. Now, I taught the regular algorithm for years, but recently I started to look at it, and it's still not helping them understand what's happening, because they're taking 7 times 5 and 2 times 5, but is it actually 2 times 5? What is it? It's 20 times 5. And so when kids look at this, they're still not fully understanding the math. So something that I've started to use, and I've seen kids really understand what they're doing here, to understand this mathematics. But once they get through this, to start to understand that it's 20 times 5 and 60 times 7 and 20 times 60, then you can start going into that regular algorithm. We know that 27 is made up of 20 and 7. And we know that 65 is made up of 60 and 5. So now when you're looking at this, you see 60 times 20, and that is 1,200. 60 times 7?
6 times 7 is 42, we just learned that.
So what's 60 times 7?
420.
And then we have 20 times 5, and 5 times 7.
35.
And I've shown this to kids, and then the next thing I say is, what do you think we're going to do with those? Well, and they instantly say, add them. When they see this, they instantly know that I've done all that multiplication, now I'm going to add. So you have your 5, your 7, and your 1. And they find out that you do get the same answer. Now, if you want to break it down even a little bit more, because adding 4 numbers can be difficult, you can even just add these 2 numbers, add these 2 numbers, and then add them together. So you can take just as whatever the student needs in order to understand the process that's actually happening, rather than just 7 times 5 and 2 times 5. And I see it all the time, even when I taught 8th grade, now that I'm teaching 6th grade. Kids forget about laying that egg. They don't put their 0, and so that they're making a mistake there. But when you look at this, you can see why that 0 is important. Because you're actually multiplying by multiples of 10 and not by just single digits.
Can't they just add straight up and down instead of going across like that though?
Yeah, you could do that as well. Are you saying take 1,300, right, and then add add those two numbers? Yeah. So I mean, there's several different ways to do that. And that's, I think that's a key as well, is just making sure that there's not just one way, whatever is best for the student to understand. Because sometimes these numbers might be easier to add going across, and sometimes it might be the vertical numbers that are easier to add. So, taking a look at that. Does this make sense? Is there anything that you agreed with what she said in this video?
I like the turtle.
It
I kinda liked it.
It makes sense, but I think there might be just too much going on that then they're actually losing what they're actually doing, and it's more of an art project.
Well, I think foundationally, you have to do all the structures in the beginning, and you have to do the foundation due, but I think that we still have some children who are gonna struggle visually
Mhm.
with their sequencing, that they just forget the processing and the sequencing. I wouldn't want them to draw a turtle head every time, but I think sometimes some of our kids need that visual part on the processing.
Mhm.
That I wouldn't want them to necessarily draw the turtle head, but maybe if they see it, that helps them remember the sequencing part. Because I have kids that just, the sequencing kills them. It just kills them on the process.
Well, and I have students all the time, they just multiply vertically. They're taking 7 times 5 and they take 2 times 6 and they're done.
Right.
But when I go back and I show them the square, that's what they do every single time because it makes sense to them.
Right.
Now, eventually, our goal is to hopefully come back to the algorithm. But when they need that extra step, allow them to do that. You may have some students that are doing the square and some students that are doing the algorithm.
We have a lot
That's
of kids
fine.
that have to give that up and go straight to lattice multiplication.
Right.
Because that's even better than that for them. I mean, we've got a lot of our
Because they
kids. that
can't
do-
look at 60 times 20.
Yeah.
And
Do you guys
for
know
us,
what
it was
lattice
like,
is?
oh yeah, that's,
You want to show them
almost
lattice?
like
Come on up,
that.
show them lattice. Come on, show
she's
them.
talking to you.
Go ahead, use the same numbers and show them the lattice. That way they can see.
Well, I'm just gonna pull up, what do we do? What was it?
27 times 65.
27, oh God, it's been forever since we've done this. Hang on.
Make a box.
And the lattice method is very similar to the square.
It is, it's the same thing, just without the space on it. So you just divide your boxes vertically. Now we got, did I get it right?
Yeah.
Okay. It's been so long, okay, so they're just gonna go through and they're going to, I didn't do it right.
Put
Here you go.
65 on the other side.
Okay, thank you.
Oh, okay.
Come on, Megan, help me out, it's been so long.
For the vertical line below, but that's
Get up there,
65.
get up there. Where are we at? This side?
Yeah.
Okay. Okay, and so then they're gonna go, 6 times 7, they're gonna go 42 this way,
10 goes in the top.
Sorry.
10 goes in the top triangle.
and the bottom is their ones column.
Right.
Then they're gonna go over here, 6 times 2 is 12, 7 times 5 is 35, 5 times 2 is 10.
It's
They
smaller
still get the
numbers.
smaller numbers.
So it's smaller, it's easy to do. And then they're gonna add on the diagonal. So they don't add the numbers that are on the outside, just the numbers on the inside. So on this, the answer is 5. On this, the answer is 2 plus 3 plus 0. So they get, sorry,
That's
they get a
fine.
5 on this
Yeah.
one. A 4 plus 2 plus 1. And get their here, and their 1. So answer is 1755.
And again, it's just another way to
But the
show
numbers
them.
are small, so they can do it without getting flustered. It stays with basic facts.
And I even had to go as far as highlighting columns for my kids because I have some who that through them and they try to add them all together. I'm like, okay, no. Here,
Yeah.
and we highlighted each column a different color,
To
and
start
I
it
had them
out.
circled, and they go, oh, okay.
And I can see where some students
And-
have that difficulty with seeing that diagonal.
Mhm.
And so,
But
but
once
some
they
students
practiced
get
it, they did better, and it was amazing, because I was over in her class, the kids, like, I would say probably 2/3 of the kids in the class would opt out for lattice instead of the regular algorithm. They found it easier.
And that's what I was starting to see with the square, is that a lot of students start to see that a little bit clearer than the regular algorithm.
And whenever we do the regular algorithm, when we speak about it while we're doing it, it's 5 times 20, not 5 times 2. whenever we're doing this.
So you're saying you actually say 5 times 20?
We say 5 times 20. We
And so-
say,
Making sure that we're saying the same thing is something that helps as
we
well.
try it so that we can draw attention to what they're really multiplying, so that there's some conscious effort into making a clearer understanding of it.
We still have kids that don't understand. I'm in 4th grade and she helps me out, and they don't understand place value. Yeah, no idea.
And I can say, I think that's a common thing everywhere. When I talk to other math teachers across the country on Twitter, it's the same thing. It's just that place value is difficult for every place. So if you're struggling with it, it's okay to be struggling. Everyone's going through that. And so we just have to help them, continue to help them with that place value. So.
So is there anything in the lower grades that we could do other than, you know, we do our calendar and we put our, you know, you put the little, the hundreds, tens, ones, the little sticks in there. You know, is there
Yeah.
anything else?
I would
that
think the
we
sticks
can
would be
do?
awesome, and then when you get to,
I think that when you're
Tens.
speaking about them as tens,
Right.
two
that
groups
would
of
help a
10,
lot.
you know, I think that helps for them to know what it really is.
Okay, so just keep that up.
And I think as the younger grades, it works, what you're doing with the calendar and speaking of, I think as they get older, we forget to continue to talk about that place value. And we have to continue to say, I mean, I'm guilty of saying it's 5 times 2 and 6 times 7 and 6 times 2, but making sure that I'm using that place value is gonna help as well.
Someone's stopping, was it really 2 or is it 2 groups of 10?
Wanted to know what we liked, and that was the fact that she called that 0 an egg, because sometimes when you're looking at stuff, it gets confused with a regular 0 when you're multiplying by a multiplier that has a 0 on it. And so, I like the way she filled it in. If you fill in the eggs, you can fill the difference between an egg and a 0.
Yes.
So that's
And
a
it-
fun thing about it.
And I've seen some teachers, they put an X there, instead of putting a 0, they put an X, that's just a placeholder for it.
Because
And
that's,
so,
I find that very confusing for some, that they don't understand the difference between placeholder and.
yeah. Why is that 0 there? Yeah, and I think that's,
And so I encourage them to just leave it off, and I tell them, if I can't see that slant, then I know you have got it in the right spot.
yeah,
And I don't like to say slant.
right. Yeah. Yeah. I mean, there's aspects of it that make sense to help, but I think we just have to make sure that we don't just jump to that and say, hey, this is how you
Exactly,
do
and
it.
that's what people are jumping to.
Gotta make sure that we're taking the steps to get there. A standard that I teach in 6th grade is decimals, and I'm using the square with it as well. Let's say that it's 2.7 times 6.5. I tell them, drop the decimal, pretend the decimal isn't there. So now you have 27 and 65. You still put your 20 and your 7 and your 60 and your 5. But then what's the key? What do we always do at the very end? Now go and see where your decimal goes. Go back to the original problem to find out that your decimal goes between the 7 and 5. I always tell my students, pretend the decimal's not there. Just multiply as normal. Yeah, don't stress out about it. Just ignore it. And that, in fact, that's what I will do a lot of the times in approaching first teaching the multiplying by decimals, is I just multiply regular numbers, then I plug the decimal in, and then they're like, oh, okay. And so it helps them.
Yeah, that way they see it's the same number, it's just, they're the same number combination.
Right.
It's just a different.
And then I think that goes back to teaching place value as well. Because at that point now I can say, well, it's not 27, it's 2 7/10. And so understanding how all of that works together. So, any other questions or comments on multiplying? What I wanted to do is give you a chance, actually, too much weight is placed on results from assessments, and I think that's something we have to be brave about and understand that, the test is going to happen. And so don't just teach them the tricks to get through it and move on. We need to make sure that we are teaching the understanding of the math. It may take you a little bit longer, but that's okay. And just make sure they have that understanding and not just how to do it. Are there anything, is there anything that you have, any tricks that you have seen that you think could help or possibly that hurt? And I'm talking any level, any kind of tricks.
Well, I think we've talked about the fact that kids are struggle with place value. And so I think if we spend time really teaching the place value and then use the place value as a springboard to teach the other things as to why are we doing it that way. And usually, expanded form really breaks down what place value is and what the numbers mean. And so if you can use place value to, or use expanded form to do the multiplication, then they're understanding, why am I multiplying 20 times 5? I mean, why is that number turning out the way that it is? And another thing that I really use a lot is based in blocks, because a lot of kids are still in that model stage, especially in the elementary school. And I'm talking 4th and 5th graders even, we use based in blocks to do multiplication at the beginning. Why is it, we're multiplying 5 groups of 10, so what does that look like? And it does take time, but I think that's one of those things you go fast, or go slow to go fast, eventually. And I teach special ed, so we do a lot of those. They have to see it, they have to put their hands on it in order to understand it.
I think that's the key. With my 6th graders, when I started doing integer operations and adding, subtracting, we got out the chips with the yellow and red on them. And at first I made every single student take some, and they had to show everything on their desk. They had to show me that they could do it. And then eventually I said, okay, you still have to take them. They have to be on your desk, but you don't have to use them, because some students were starting to understand the process of adding and subtracting those. And so it allows them, when I said that everyone still has to take them, it allows the students who still need that not be embarrassed that they're using them, because they're really thinking everyone's using them. But it's just that gradual release. But also the thing that I have to, one of my biggest frustrations right now is, I used to teach in Kansas, and during assessments you could have all your manipulatives that you have used in the testing room. You could not give them to the students, but they were there, and students could get up out of their seat, go get what they needed, and go back and sit down to solve the problem, then take it back. And that's one of my
You're kidding.
No.
Oh, sorry, I just had to.
No, it's fantastic.
Wow.
And it's
fantastic.
wonderful, because the
Those
students,
kids do it.
if they're used to using it, they're used to going and getting it on a regular basis, it's helping them use their
And the
resources.
assessment
But
is
it
not
makes
easy
sense. I
than
mean,
a
it
regular
frustrates
day.
me when, just because they don't have an IEP, that, because they do use manipulatives and everything,
All
so,
the time.
but I thought it was all across the board that,
No.
so we're not
It's
even
not
on
a
the
level
same
playing
playing field, not just with our own district, but with the whole daggum other
Well, they
things.
can't use calculators.
Yeah, they
Well,
can't
I
use
understand
calculators,
that,
but
but
to
I
be able
mean,
to
they
go
can
and
use
Yeah, but-
manipulatives.
Yes.
So we're
teaching
being-
three-dimensional
we're being
figures
compared
for
by
students
other
to actually
states.
hold one as a review rather than having to visualize it in their head. 6th graders can't visualize that stuff in their head yet.
And it's
But
an
they can
active
actually go
So
experience for
geometric
them.
solids, they can go pick one up and
Yes.
think about it.
Yes, they can hold it, they can count
Wow.
the faces on it, but they still have to know that it's called a
Well, yeah.
triangular pyramid. They
Well,
have to
yeah,
know
but
the
ours
name
have
is.
to create
And they
it.
have to know
Yeah.
nets, and
Yeah.
they have to,
Uh-huh.
Well, yeah, you can't label things.
Yeah, you
yeah,
can't
but-
label it, but it's
But our
there.
kids know
It's-
it.
Yeah,
Right.
exactly. Yeah, and it's like, it's not even a different, it's not a different day. for
And
them.
so,
It's just-
I think the struggle we have also is now taking, because we use those, but now you have to teach them how to use it without actually having them. And that's like with the chips, I was teaching them, put R's and Y's on their paper, and you would see some kids writing out 20 R's and 35 Y's to figure out that the answer is 15. So, but, yeah, to be able to use those things,
I had no idea.
they could actually use it.
I'm gonna cry even harder now. I just do, I'm sorry.
I hate to go off of our great discussion about testing here, but thinking back to the whole place value issue, when I'm not as far removed, being just new to the profession. When I was taught face value, we did something called face, place, and total value, and I have not seen it since my days in like 6th and 7th grade, where your place value was, 1s, 10s, your face value, Anthony, if I could go up to the board
Go for it.
and explain it. And I don't know how anyone feels about it because I haven't seen anybody use it since I was taught.
I've never seen
Where
it.
taking a look at your 27 here, the 2, place value is the 10. The face value of it is just the immediate number you see where it's the 2. And the total value would be the 10 times the face value, which would be the 20. And so I don't know if that was just
Teaching the difference between the two.
teaching the difference between the two or something that's actually,
So there's place value and face value.
and then the total value is the two of them, 20. So total value of that 2 would actually be 20.
Okay.
Wow. Yeah, I like that.
That makes sense. Thanks.
Yeah,
That makes sense.
Place value, face value, total value.
yeah, face times place equals total value. Again, when I was in college, I asked, because I teach middle school math with Anthony, when I asked my college professors who taught the math pedagogy, they'd never heard of it either. So I don't know if I'm just crazy or, well, I am crazy, but not for that reason.
Well, they're always changing our terminology we're supposed to be using. I'm sure it's
use it with different names.
yeah, I'm sure it's a teacher that had it.
Two, and its places to tens, and the value of that number is 20. So I called it different things than him, but I don't know where I saw it. I wasn't taught that way, and I can't remember where it came from.
I like the vocabulary though. Maybe we
Yeah.
should just use the triple layer. The ear flap.
But a lot of the ideas that I'm getting from came out of this book. It's called Nix the Tricks. It actually started out on Twitter, where a lot of math educators were just talking about all the tricks that are there. If you want to pass around and look at it, about all the tricks that they see that kids have learned, and then they suddenly don't understand why. Like the next year, they're like, "Well, I heard about this method. Okay, show me." And the kids couldn't do it because it was just a trick at the time to get through the lesson. And so a lot of educators, or a lot of math educators, started talking, and there's an online source, and the author, she's not really the author, she's just the person who actually took everything that was on the Google Doc and just put it into book form. And the Google Doc is still available. You can go add things to it. You can go see what else is there. But it gives you the trick that was taught, but then it tells you also what could you do instead of that trick. And so that's where it talked about with the butterfly. Don't just teach the butterfly, but actually pull out fraction strips and help them to understand it more.
Just on something that I noticed when I was teaching, like equivalent fractions, because I had my own set of, you mentioned fraction strips, well, I had fraction circles, and in high school, I still couldn't get fractions. And then when my mom got me a tutor, and I was like in my senior year, she didn't have fraction strips, but she had fraction circles, and when she used that, all of a sudden, it clicked. And I was in high school and about to graduate and didn't know anything about fractions, but because of those circles, I don't know why, but it worked. So my first year teaching, and I pulled kids back and asked them to use the fraction strips that they had, and I asked them to find equivalent fractions for like 1/2 or something like that, and I had one just break down, start crying, and he goes, I don't get it, so I took him away, and I gave him the circles, and he got it instantly. So.
Well, I could see where a difference in that, it would be the circle, you can see the circle. When you're thinking fraction strips, well, how long is my strip? Is my strip starting here? Is the strip starting here? I could see that could be more difficult, but when you see that circle, you can see if it's whole or not. So.
One thing I do when I'm adding and subtracting, or the denominator stays the same, is I show them the word denominator and show them how the MOM is actually from the Latin meaning name, and at that point, it's not a number, it's a name. It's the name of that size piece. So treat it as a name. Anytime you put a TH on it, it becomes a name and ceases being a number. It's the name of that size piece that the whole has been divided into. And that's why it stays the same.
That's very good.
That makes sense. That's bringing in the vocabulary into it and the understanding.
That's like numerator has the NUM is the number of that size piece that we're concerned about.
Ah, I love that.
And that's understanding.
Hey, my
the
English
fraction.
people over there, you guys getting that so you can use that in your class?
That's understanding what the
Root
fractions
words.
Yeah.
is, rather than just trig.
It's not just a word, and see, I never knew the root of denominator or anything like that.
Can you run that by again? So
From the name.
Can you say that again so people can get that? And I'm actually videoing this, so I will put that out, and so that piece you just said will be there, but you want to repeat that for people?
When you write the name denominator, you will see DENOM, and it means from the name. Okay, and nombre, of course, you recognize that. Okay, so, NOM, NDENOM, NOM means name, and so that is the name of that size piece. When the whole has been divided into, let's say, fourths, then that size piece is called a fourth.
Is that right?
No, it's got a
NUM is from the
D-E-N.
name.
So DEN, right? Come on up.
Okay. All right.
It's not just me. And I think that's the big thing. We're all learning from each other too. I'm not the master. to this.
DENOM, from the name, this means name. And then I'll go through different words that have name and number and noun and all that, but come from the word, the Latin word name. And so it names that size piece. And so now that's called a fourth, and it's got a TH after it. And when you put a TH after it, it becomes a name, it becomes a noun. Okay? And so now, okay, how many of those fourths are we concerned about? Well, we're talking about 3 of them. And that's the number of that size piece that we're talking about. And so when we put 3 of those size pieces together with 2 of those size pieces, we get 5 of those size pieces. And that's why you add the tops, but the bottom stays the same.
Or people just learn something. Awesome. Thank you very much for sharing that.
Okay, where do you teach?
Juvenile Detention Center.
Excellent. Wow.
They're fortunate.
I do think
Yes.
there's a component of educating parents in this, because you hear parents, when you do math with the box up there or something, it's the new math, and you see people on Facebook or whatever all the time really great. I don't know how to help my kids with this new math, and why are teachers teaching this new math? Well, it's not.
It's teaching the understanding.
Right. So I think there is a part where you have to do some educating of parents as
Would
to
it-
what you're doing.
Would it be something to where you can record your class as you're teaching it, and then you post it online just so student or parents can go and go see exactly what it is, rather than just saying, well, this is what we're doing now. They actually can see how students understand it more.
I think something needs to be done to explain it to them. I mean,
Or
whether
maybe
it's
parent
that.
involvement night.
Do what?
Maybe a parent involvement night, like the title is parent involvement night, or PTA meeting, a little.
But I think it still can be difficult, because there are too many people out there who, they're just not open. That's not how I was taught.
Well, it's scary, you know?
Yeah.
It really is, you know,
When-
kids are instructed with something that you can't do. And you
Yeah.
don't understand why.
Well, and I'm one, I don't say, here's 40 problems, go do these tonight. You know, I do it in the classroom, and if they can show me, they can understand 10 problems right there in front of me, you're done. I mean, you're understanding the concept,
Why beat a dead horse?
so. Exactly, reading papers goes away.
Well, what I was gonna mention is, I saw a video last night called Throw Out PEMDAS. And really what I understood was they were talking about the application. I mean, something like that is real helpful, I think, but it's knowing how to use it.
It's in
And I
that
think
book.
that's what you're talking about.
It's in that book, and it talks about, PEMDAS, they get stuck on parentheses. My students see this problem. What do you do first? Oh, parentheses. there's nothing to do in the parentheses. It's just a 3. And they're like, oh, well, multiplication. Okay, there we go. And so in the book it says don't use parentheses, things like that. Use, G, it says Gma. Your G is groupings. And the reason you're looking at groupings is later on down the road you have problems that look like, suddenly where do you start? So you teach them groupings. You always start on the inside of the groupings and work your way out. Then you go to exponents. Then you go to multiplication, and this is where you have to teach them multiplication and division are the same thing. And so one is not more important than the other. We say multiplication, but division is implied because they're the same thing, just opposites. Same thing, or not opposites, inverse operations. Addition is the same thing. You're just saying addition, but subtraction is implied.
But you can teach them the same process with P in parentheses. Say, engage your brain, look at it, anything that's got parentheses, brackets, and groupings. Because you look at the 3 and go, okay, so what are you going to do with that 3? And they look at it and you go, think about it.
Right. Right, and that's
not a stretch. And they look at it and they go,
But what about when you go fraction over a fraction? Or what, you know, when you're using your fraction bars, your grouping symbol.
that.
Yeah.
It's
So
your
that's why you
groupings,
want grouping
and it,
symbol.
right, it's groupings. You're grouping your numerator together and you're grouping your denominator. And so that's where it's still grouping that way.
you can teach that as an implied as much as you can teach multiplication and division implied together, or addition and
Right.
subtraction implied. I mean, it's all semantics on it.
I didn't remember, one little tip or trick that irritates me. I teach a remedial 8th grade, and so I have kids that come to me that don't have 5th, 6th grade skills, and they're trying to do some algebra. One of the things that irritates me is the zap zap, or the clap clap, or the snap clap, or I don't know what it's not, where you make the,
Click, click.
yeah, whatever that is. Because when I work with them to try and solve equations, when we have an x minus 2 equals 4, I say, what's your first thought? What are you doing here? What is your inverse operation? They go, click, click. I'm like, can you show me click, click? And then they do that and they're like, I'm done, right? I'm like, no. So there's no understanding there that click, click is like, if you have 5 minus 3.
You're actually going
5
to
minus
change
negative
this
2.
to
Positive.
minus
Yeah.
the positive.
5 minus, yeah.
If they're subtracting a negative number.
Yeah.
Same thing, yeah.
Yeah, and yeah, they
Or
have
minus
that.
a negative 3. They want to do it when they're subtracting a negative.
Because it's click, click.
So,
Oh,
yeah.
for goodness sakes.
And-
Why
But
would
it-
you
but
do
it-
that
it-
when you're just trying to
It's
teach
not
them?
it's not the understanding process of it. The way that I taught those, again, I use those counters. But of course, how do you explain to the kids that when you're subtracting a negative, that they all have to you flip them over, because that's initially what you're doing. I have a number line, and I show them that when if that's my negatives, this is my positives. When you are adding, then you want to face the positive direction. When you're subtracting, you have to face the negative. But then if your number is negative, then you actually go backwards. If your number is positive, you go forward. So then at that point, you're seeing the subtraction, you're seeing the addition. And so I'll get kids up and actually walk back and forth. And which way do you need to face, first of all, and that's adding or subtracting. And then the other one is if it's a negative, you're going backwards. If it's positive, you go forward.
And that's the perfect bridge to what we do at the very little when we start, adding and subtracting and doing regular
But that is
numbers.
so much faster for their brains, and that's why they do it.
Right. Well,
We'll just have them wear their tap shoes to class and they can click, click.
Well, dealing with older kids, and I agree that fractions is a real problem because 90% of kids have somebody left and not know the fractions. But this positive and negative stuff, dealing with the older kids, what I do is I use money, and I say, okay, you owe him $5, you owe him $10, what's your status? I say, okay, you owe him $5, you've got $6 in your pocket, you settle up, what's your status? You understand money?
Yeah.
And owing people rings, yeah.
Yeah, that's another
When
way.
you start subtracting negatives, they get confused, and that's why they do that, because it's very clear and easy for them, and they have an accuracy rate that's higher, and that's why they do it.
But
It
it's-
is, I'm just saying it is.
But once you get past this unit and you start using it in your other things, they lose it. They don't have that again, because it was the trick that got them through the test, and now it's lost. So, I know, I'm seeing this time. I appreciate your guys' input. Again, if you wanna go back and watch this, once I get it up, I'll share it out. Go back and re-see, get some ideas.
They're not gonna sign anything.